Today we're going to be doing a gel electrophoresis lab. At your lab station you should see several things. One of the things that you should see is a gel, and the gel, if you notice, has little holes in it, or wells, and those wells are going to be where you're going to put your samples. So the gel, if you actually notice too, is sitting in TB buffer, or TBE buffer, excuse me. And that buffer, I'll talk about in a second why that's there, why that's significant. The gel is actually made out of agarose, which is the same thing that we used for the slime mold lab earlier this year, the bottom of the petri dishes that you developed your mazes on. In order to make the gel, before you came in, I poured the agar into the wells, into the chamber, and then I also inserted the comb, and the comb created the wells, if you were curious. Like that. Eventually you're going to use the actual electrophoresis chamber, and the chamber has two charges. It has a positive charge and a negative charge. Hopefully you should start to think about why there's a charge. You have a charge because you're going to put the gel that has the samples in it inside of this chamber. When you turn on the power source, a charge will flow through. So it's really important that you put the wells on the negative side, so that because DNA is negatively charged, it will move towards the positive end. If you put it the other way, if you put the wells or the samples towards the positive end, it will just flow off in the direction of the positive charge. So you'll waste the samples, and we don't want to do that. So there are two different types of pipettes that we're going to use. Freyland, Virginia Tech, sends us these fixed pipettes. So the fixed pipettes it tells you on the side, it's 20 microliters. This is really important to note in your lab paper, in the materials section, as you learned with the slime mold lab as well. So there's a hard and a soft stop, and I'm going to talk to you about that more when we actually get to loading the gels. And then this pipette is something you would see more at a university level. They're a little bit more expensive, and you can change how much is going into the pipette. So you can change the amount of microliters, and you would do that by using the dial. And this again, this has a hard and a soft stop as well. Both pipettes you would need a tip for. So as soon as you're done as soon as you've used the tips, you can throw them away. So we've talked about sterile techniques before in class. You need to use a sterile technique with this. So you would put the tip on, and then you're going to use this when I talk about loading the wells later. There also, here is a beautiful micro centrifuge tube stand, so that you can figure out, okay, well, I remember that number 4, this is where this sample is located, number 6 is the sample B, so you can make notes of that in your lab notes as well. And this is the TBE buffer. The buffer is really important because you're going to put 200 milliliters of the TBE buffer into the chamber, and that's when you're going to give it a chance to run, so that it's moving towards, again, that positive charge, excuse me. This is the power source. So we're going to plug in your individual chambers. This particular power source will fit 3 different chambers in that, and I'll show you how to use that later. And then this is a microcentrifuge. You can see all of the holes. It's really important that when you put the microcentrifuge tubes into the microcentrifuge, that you're evening it out. So if you're going to put one in chamber 20, you also put one in 10. If you're going to put one in 4, you would try to put one right across from that, so probably in 14, to make sure that it's even, so that when it runs, because it runs at an incredibly high speed, much faster than something like your washer or dryer, make sure that it's not imbalanced so that you can hurt or break the machine. First step for loading your gel would be to put on gloves, because you need to make sure that your skin oils don't go into the gel. Here's my gel. Again, it's sitting in some TBE buffer. The significance of that is it's going to help carry the charge through the well. I'm going to take my gel out of the buffer. If you can imagine, this is like Jell-O, except it kind of has holes in it. So in addition to the fact that it's really sensitive, it already has some perforations. So you need to be especially careful when you're pulling it out of the bag. Now that my gel is successfully put into the electrophoresis chamber, I have to add 200 milliliters of TBE buffer. I'm going to use my beaker. So now I have my TBE buffer, 200 milliliters, and you're going to pour the TBE buffer on either side of the gel. Be careful not to pour it right on top because you don't want it to shimmy off to one side or to the other. Now I have my gel electrophoresis chamber prepared, has the TBE buffer on top. It's really important that I put the buffer down before I put the samples in so that the samples don't get flushed away. Now I'm going to take my samples and I'm going to put them inside of the centrifuge. So I'm going to put them inside of, again, well 1 and the one immediately across from that, so 10. Then I'm going to shut my centrifuge and I'm going to turn it on so that it can spin down the samples to the bottom of the micro centrifuge tube. It has to come to a complete stop before you open it. You only have to do it for about 30 seconds, definitely less than a minute. Once you've noticed that it's come to a complete stop, which is not yet, then you can open it. So now my samples are spun down. So you can see that all of the liquid is at the bottom of the microcentrifuge tubes. So once again, the stand is useful because you can make note of what sample is at stand stage. The whole 4, 6, and 9 is what I'm using. Then you're going to open up each sample one at a time. So as you open up the sample, it's really important that you're using your pipette and you're using a different tip each time. So when I go to withdraw the sample from the microcentrifuge tube, I'm going to push down to the soft stop. So you'll be able to feel, you should test this out. We'll practice on some practice gels before you do this. But you go down to the soft stop, go down to the bottom. You're going to draw up the sample into the pipette tip. Okay, so now you have the sample in the micropipette tip. You really need to make sure that when you're putting the sample into the gel that you don't poke through the gel. As you can see, the micropipette tip is pretty sharp and the gel, as you know, has holes in it, the wells that we made while making the gel. So it's already a little bit sensitive. So if you take the micropipette and lay it on the side to let the gel actually provide support for the tip in the well, and then you're going to push the stop all the way down to the hard stop to release the sample into the well. Make sure that you have the tip in far enough, though, that the sample is not going to run through the TB buffer. You want it to kind of be sucked down into the well. So this is the top for the gel. Now that I've successfully loaded all of my samples, I have the buffer on top. You would then connect the top of the chamber to the chamber. So you would slide, the red is going to match up with the positive. The positive is kindly labeled also in red. And then the negative is going to be black. And again, the negative sign is in black. So you're going to slide the charged, or the will be charged top on. Then you successfully have everything hooked up, nice and color coded. You're going to put positive, the red, notice there's a red outline inside the hole, and the negative, black outline inside of the hole. Then you're going to turn the power source on. At this point, if you have any questions, make sure you call me over and I can come help you. But you're going to turn on the power. You notice that the red light did come on, and you can see that there's a certain amount of voltage. Again, we're trying to get the sample to move towards the positive end because DNA is negatively charged. That's why we decided for the charge orientation there. So you're going to let this run for a while. Last year, on average, it took about 10 to 15 minutes, but some people it took 8, and then other people it took 25 or 30. So you need to make sure you have one person from your group monitoring this to see when the bands get close to the end. You don't want them to get all the way to the end. You definitely don't want them to run off. If they run off, it's not an accurate sample, and you might have to start over again. So make sure you're having someone watch. When you're done, don't be alarmed if you don't see pretty blue bands. If you've ever seen gel electrophoresis gels in the past, the bands won't look exactly like this, but after we go through the staining process on day 2 of the lab, you will start to see the bands appear in a nice blue color, and you can compare it with the DNA ladder that we use in the lab to see which suspect committed the crime, or for the protein gel electrophoresis lab, which protein we're testing for.